I want to say a word about number 19, Part D, before I move on. When you write an interpretation of a confidence interval, there's a couple ways you can go. The one thing you don't want to say is that um, there's a 90% chance that the true proportion's in here. Chance is about random events. The proportion's not random. It exists somewhere, it is, right? It is truth or whatever. So there's no proportion, or excuse me, there's no chance. That said, you could say, I'm 90% confident that the interval I created here, between here and here, contains the true proportion of people that will have headaches from Lipitor. Or you could say, look, if we go out and collect 863 patients over and over and over and over and over, then 90% of the intervals we create that way would contain the true proportion. Those are the two things that are okay to say. But it's not okay to say, there's a 90% chance that the true proportion's in there. It's not chance. Chance is about things that haven't happened yet. They're about the future, about randomness. This isn't random. There is some true proportion. We just don't know where it is. That's a very different ballgame. All right, so that's all there is to say about that one. Next, I wanted to move on to the next problem, which is 9.3 number 27, which is on the next page. That's going to involve, here it is, figuring out a sample size. Now, there's a formula for sample size. You know it's coming. Let's see, let me get to it. There it is. There it is, right there. So there's two of them. One's if you have a prior estimate, p hat, and one is if you don't. Let's go back to the question. And it says right here, we're doing number 27. A researcher for the U.S. Department of Treasury wants to know how many pennies that they have to go get. Right? What size sample should they do if they want to estimate to be within 2 percentage points with 98% confidence? All right, so let's see here. Our confidence level is 0.98. The within, that's the error. Now be careful with this. It's a percentage, so it's actually 0.02, right? Tricky. I know it's tricky. Then we're going to need the prior estimate thing, which I'll deal with that in a minute, but that's for part A. But before I go anywhere, I'm going to need Z alpha over 2 to be able to do this. I mean, look at the formula for a second. It's got Z alpha over 2 in there, so we're going to need that critical value we've been finding. So first let me find alpha, which is 1 minus that. Then let me find alpha over 2, which is that value divided in half. Then the critical value, that's going to be the Z alpha over 2. That's equal to norm S inverse of, now, 1 minus that guy, right? That way you get the positive value. Next, we need to know the prior estimate p hat. P hat they gave to us in the problem as 0.15 right there, 15% from an old poll that they did. So let me go back here, it's 0.15. All right, so what's n? N is equal to p hat, that's this guy, times parentheses 1 minus p hat again. Another times, forgot that, parentheses z right here, divided by the error. Error is right up here, 0.02. Got to change it to a decimal. Close that and square it, caret 2. Now, even though this is really low, we still have to round it up to 1726. You can't ask 0.25, or excuse me, 0.041 of a person. So you've got to round this up. There we go. All right, we're running out of time, so I'll be back for the last portion in just a second. But this one was the answer to part A. I'll be right back for part B, if you click on the next tutorial, that is.